All right, we're getting into notes on cube roots. We're going to use the same prime numbers. 2, 3, 5, 7, and 11 are kind of rare. 13, 17 are ultra rare. We got square roots, but today we're going to use cube roots, which is CBRT on Desmos. And we already checked all 4 of these questions by typing in CBRT, and it turns out that CBRT 216 is just a 6. So we already did number 4, CBRT 216, because it's just a straight up 6. Okay, it's a perfect square. We don't have to work much harder. Now, let's do number 1. When it comes to these perfect cubes and trying to break down cubes that are not perfect, it's the same method as squares. Same prime numbers. Let's start with 120. 120 divided by 2 is 60. So just like we did on the square roots, we're doing the same thing for the cube roots. And 60 is not prime. 60 is 2 times 30. All right, this is not too bad. And 30 is 2 times 30 is 2 times 15, right? Hopefully you're starting to get pretty good at this multiplying thing. And 15 is 2. It doesn't work 2. It's 3 times 5. I hope you know that 15 is 3 times 5 by now. Okay, that's where we're going to stop because we have 2, 2, 2, 3, 5. And once we have all these nice prime numbers of 2s and 3s and 5s, rarely 7, we're going to stop. We're not going to use these big non-prime numbers. We're only working with 2s and 3s and 5s and rarely 7. Now, there has to be something different between square roots and cube roots, okay? So think about it like this. If you have 5 squared, and that means 5 times 5, what does 5 cubed mean? I think I heard somebody whisper it in the faintest little tone. 5 times 5 times 5. So for squares, we were circling doubles. What do you think we have to do for cube roots? We got to circle triples. Okay? So you can see up here, it says trios, because that's what we're looking for is triples. So I don't care about doubles anymore. Doubles means absolutely nothing. Now that we're doing cube roots, I'm seeing 2, 2, 2. That is a triple 2. Then I've got 3. That's a lonely 3 with no buddies. Then I've got 5. That's a lonely 5 with no buddies. And our rules are exactly the same for finishing our question. Circles come outside, and leftovers stay inside. 3 and 5 makes 15. And it's the same thing as before. For every circle, only one of those numbers actually makes it out. So the 2, there's only one 2 that actually comes out. It's the same exact thing as square roots. Okay? The only difference is that we need circle triples instead of circling doubles. So number 2 is a great big number, and we're going to get a whole bunch of stuff. I'm going to go through this pretty quickly. Okay? 1024, it's actually a pretty popular number in mathematics and computer science. 2 times 5, 12. 2 times 2, 56. 2 times 128. 2 times 64. 2 times 32. Keep it going. 2 times 16. 2 times 8. 2 times 4. And 2 times 2. So 1024 is a really popular number in mathematics, in computers. If you work with computers, if you work with cell phones, if you work with technology as a job, 1024 is very popular because it is a number created entirely with 2's. If you look at this, it's 2 times 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 2. It is a number totally built by 2's. And if you've ever heard of, never mind, you know what, we'll just keep it going. We're running out of time. We'll keep it going. If I'm looking to circle triples here, we've got triple 2's and triple 2's and triple 2's and one leftover 2. All I need to do is follow the same rules as before. Every circle puts out one number. So that's 3 circles, a circle 2, and a circle 2, and a circle 2. And then we have one leftover 2. So our answer is going to be an 8 on the outside and a 2 on the inside. The reason it's an 8 is because 2 times 2 times 2 is 8. And the reason it's a 2 is because there's only one little 2 on the inside. Don't forget your little 3 on your cube roots. And this last one is not nearly as big as 1024. It's not very likely, not very common in math class that we deal with numbers bigger than 1000. Last question, lunch is around the corner. 324. Okay, we're going to split it up, which is going to be 2 times 162. If you're not sure how to do this, one last little reminder, just type it in, 324 divided by 2. And if 2 doesn't work, try 3, and if 3 doesn't work, try 5. But 2 works, and you get 162. And then take 162 and divide that by 2. 81. Divide that by 2. But what is 81 divided by 2? It's a fraction, so try 3 next. I get 27. So it's 3 and 27. 27 is 3 times 9. And lastly, 9 is 3 times 3. Okay, now stop here for a second. We're at the point where we have prime, 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 prime. It's all the way broken down. The only new step today is to circle triples instead of doubles. That means we have a leftover 2 and a leftover 2. This is pretty important. We have double 2's, but I don't care about doubles. I only care about triples. So even though you have double 2's, who cares? They still have to stay on the inside with the 3. So my final answer here, the only thing coming out is a 3. On the inside is a 2 and a 2 and a 3. And I need to multiply all that stuff together. Let's just use a calculator. 2 times 2 times 3. Multiply all that together and I get 12. That means 12 is on the inside. Now that is all of our notes for the day. Before I kind of end it up here, remember that for number 4, you could have done all this work breaking it down, right? 216 is 2 times 108. Or you could type in CBRT 216. When it tells you a nice number, you are done. That is it. Make sure you circle triples and make sure only one number comes out. Even though it's 333, only one of those 3's actually comes outside. Okay, that's it for the cube root notes. They're only 10 minutes long, not too bad.